Discussion, but first I had one clarifying question, which can you just once more, because it popped up a lot in the second half of your talk. So, what is exactly the role of the attentional anchor? What is it here, and what do we conclude from it?
Okay, so attentional anchor. What we saw in the eye tracking data of a lot of students is that they are their eyes move up and forward, and maybe this one is even clearer. They move here from the left to the right, and there is nothing there in the graph. I mean, there is not a straight line in the graph, but during the eye movement and also in the interview afterwards, they said, well, I was looking at this horizontal line because we want to make all bars equal. So for the students, they kind of construct a new thing, object or whatever you want to call it, that isn't there, that wasn't there yet, and we didn't expect that in the beginning. Actually, when we designed the first pilot, I was quite afraid that we would not find anything at all, because I thought this is so clear, the weight scale, where it is. How can students do this wrong? And then from that, these horizontal lines and the vertical lines emerged. And I think, and it didn't do that in one student, and not only in the pilot, but it emerges many times. So that's why we call it, an attentional anchor. Something that is a construct that students make to find a solution for the problem they encounter in the task. And probably if you ask some other researchers, they can give you a clear definition, but...
And how did it exactly support task design?
Well, it's not... okay, so once we know that this vertical anchor is very important, and also the horizontal position of the anchor, we could have designed the task from that idea as well. So how can we support students in finding the horizontal position, which is actually what the first task is doing, and how can we help students thinking about this vertical line or vertical thing that is connected to how many cases there are in a bar. And that was the second and the third task. And when you combine that, you get the mean, and that was the balancing task in the fourth task, where you have both the position and this mean line.
All right.
Yeah, you're welcome.
So I think for the discussion there were during the talk 2 discussions, or perhaps 3, that were immediately parked.
Yeah.
To say. So I would like to perhaps start with picking those up. To the people who actually raised the issue, do they remember? There we go. That was not really parked, but there was another one that was parked also.
No, but I think that there is much more
To say.
I think important issue really, right?
So should we pick that one up first and then we come back to the paper? Because I think you...
Yeah, because...
I already asked my question.
So, I think your discussion was a bit about this. We could make all cases as high as the... How do you say that? Yeah, but the cases as the height of, one case in one bar, as the scale on the vertical. And in this graph we did, this is a histodot that you can use already on VuStats. But as Anna said, we purposefully did not do that.
Yeah, I think what I see as an important continuation of this discussion is your arguments as educators. We want our representations to be as visually sticking as possible. And since that, this one would really help students to see that bars would be that high. But an idea behind embodied design is that it's not just about grasping visually, but about coordinating manually. So we purposefully want students to think, how high should it be? From where does this height come from? And in case all the balls are already piled one on top of another one, there is no point to think about it. You just write it that high and that's it. But if there's somewhere at the bottom, you need actually to calculate and consciously make it that high. And I think this is an important difference between providing a visual aid and providing a really embodied design.
Yeah, but you have you then have in one picture you have two different ways of depicting your data, and well, I can see why this helps me in the sense that I have a case that I put into a bin, and I can see where it is in the bin and so on. Whereas if I move something in, well, why should I have that in the same? Why should I have the bars in the same picture as the dots? I mean, then it would be you would put them somewhere else on that. Put them in a different graph.
Yeah, may I clarify? Do you mean that to put some abstract orange balls and histogram is mathematically not correct? To put them in one picture?
But it's quite confusing because you give them some size, and for students, I mean, yes, I know it's just a point, but they look like objects, and you work with them like objects because you have to slide them all along and so on. So I think that all the students will see it as objects, and they would expect something like this, and not something as well just behind the dots doing something quite different.
I think this very important empirical question that could be really empirically tested, and yeah, I'm really curious.
Yeah. Yeah.
To follow up on this, if I look at this graphic here, they don't have to do any counting because they're already stacked. While in your solution, sometimes there were 3 balls next to each other, which I like, and then they had to move it 3 times up. Because I think there is an addition here where they already ordered them, also in height, so they're never next to each other. So now the dots are as high as the bars,
Yeah.
which I think is a different discussion. I think it might be beneficial to make the pins or frequency of 1 as high as 1 ball, but I like in your design that you can have 3 of them next to each other, and then I have to stack them up, and here the stacking up is already done for them, so they don't have to conceptualize that.
Yeah.
I think it's more difficult to see 1 dot and then having to have a sort of different unit where 1 is twice as big.
Yeah.
That I think I find confusing.
Okay.
Yes, I'm thinking that it could be confusing, but also if you pay attention to it, even clarifying, because it is something different. Here it is a measure of height, of some kind of size, while in the histogram it is really about counting. So it's 1, not 1 side ball, it's just 1 ball.
Yeah,
so it is.
but in such a messy dot plot, I mean, of course, it's a data point. It's just one number, and why can we stack up upon each other? I mean, actually, they should be all on the same line, because the data you've made it because you've given them some size.
Yeah.
So you're mixing.
Maybe you should put them in a bag under the horizontal line, and then they can count lines up or something like that.
Okay.
It's a mix.
Before you got to this, you put things in bins. And then when you started that, you had this activity where they added data points themselves. And then you had a very weird dot plot. Not just messy, it was weird. And
Yeah.
things were going diagonal and so forth. And I was thinking, wouldn't that be a very nice situation to start a discussion with the students? Couldn't we do better than this? What's the problem here? How can we solve it? And along those way, just gradually move to the histogram or sort of bins of stacking or whatever to get to the histogram.
Okay, thank you. Yeah.
I had another question about this network that you showed in the final slide. Yeah, this one. Yeah. So you had this very nice illustration of conceptual difficulties that there are with histograms. And then more or less quite suddenly you had the idea that the solution might come from embodied cognition.
Uh-huh.
So I was wondering about the missing arrow between those two. So could you say something or speculate something about the character of the conceptual difficulties and why they could have been solved with embodied design?
Okay, so what?
I think there is a kind of relationship, and it's not empty.
No, what I consider conceptual difficulties are difficulties with two key concepts, data and distribution. And if you look into the literature, then you get all different kind of misinterpretations. But I summarize these misinterpretations into a conceptual difficulty. And in the design, I use these misinterpretations that are related to one key concept to design my task. These misinterpretations themselves don't give the idea of an embodied task. The embodied part of the task comes from other sources, like the embodied cognition theory and the attentional anchors. So the information from the statistics education literature through the conceptual difficulties goes only to designing the statistical tasks. So that's why we took a dot plot. That's why we made this histogram overlay on the dot plot, and so on. Does this clarify it or not?
Well, I could think that one of the problems is the interpretation of the axis, and that you want students to be more aware of what's happening there.
Yeah.
And therefore create activities where they're really acting on the axis.
Yeah.
And so they're embodied. So that might be a reason why an embodied design might prevent these difficulties.
Yes. Thank you for this argument. Yeah.
Then, no, let's first understand.
Okay. Go ahead.
I was wondering about this horizontal sliding.
Yes.
I can imagine that it's a kind of embodiment. You do something, you act. But is there a problem with the conceptual probably conflict that you the concept of height is not a horizontal concept in a way, so you slide it horizontally. Are there alternatives for horizontal sliding, like the concept of weight? I think an embodied form of weighing things. Is that? Can you imagine other solutions than horizontal sliding for all concepts, whether it's height or weight or whatever? So that's just, it is a sort of embodiment, but it is a bit of very abstract. You help your memory system with sensory motor extras, but it seems a bit artificial. Embodied in the sense that we know what weight is and what height is from our experiences, which are different from horizontal sliding.
Yeah.
But that's just a question.
Yeah, well,
what the answer could be.
Neither do I, but I try to formulate anyway. One of the things that we found in our eye tracking study is that some students, even with the dot plot, thought that the mean value is a kind of horizontal line. So they counted how many dots, the heights of the dots, so how many dots there are stacked on top of each other, and calculate a kind of mean height of this stacking instead of the mean of the relevant variable. And that made us think that we should make them very aware that the variable, whenever it's, even if it's height or weight or whatever, is in a histogram and in a dot plot on this horizontal scale. So the reason for designing the task is raising that awareness. Of course, weight...
Embodied experience of something which for most people will not be embodied. So that could be helpful, I doubt it, but it's new. It's kind of helping you to imagine the concept by doing things horizontally.
Yeah.
So you create an association.
Yeah, also with the number line idea. Yeah. Yeah, okay.
Similar remark about finding the balance,
yes.
Find the mean. I can see how it helps in developing the skill of finding a vertical line that divides it in two equal parts, but I don't see how it connects to the conceptual understanding of mean.
It's not two equal parts, it's two parts which have equal moment in terms of force and distance.
Yeah.
If you see it like physical.
Well, that's the meaning. What you say is the meaning.
Yeah. Yeah, so that's one of the reasons why we took the mean, that it's not like you split the area. So you really have to find the point where the graph is in balance. And if we have like all bars close together, then it will be like, somewhere over there. But if we add one bar here, then we have to adjust this balance to that high bar over here. So
generally, sorry, I'm as a moderator, I didn't even look to the side. But, I'll finish my sentence anyway. You have to explain how the movement contributes to the meaning making.
Yeah.
So how does doing the actual sliding for horizontal sliding either with the balance or with putting the dots on the right point, how does this gesture, making this gesture, correspond, contribute to the meaning making?
Yeah, that's a good question. I have to think about that. Thank you. Yes.
What value are you using for the balance? Because are you using the actual values of the data points, or are you using the points of the bin?
The approximation, in that case, we don't know data already, it's reduced. This information is reduced, so we use just the mean of each.
So actually you say, they're all the same.
There are alternatives, and that was the same in the eye tracking experiment, that you don't know exactly the mean. Even if you have the exact bars, you don't know the exact mean because you don't have the original data.
No, but because you said, well, people often make the mistake that all the data in one bar, they have the same value, but it's not. So actually you should use the mistake. I think so. I'm afraid.
Yeah, but in that case, we might use a graph like that one. Then we have the actual values, and we still have our histogram.
And then you would have a different balance.
Yeah.
That would
yeah. So, thank you.
You can just respond.
Yeah, I wanted just to say that I think it's an issue if we can at all speak of a mean of a histogram. If we can speak of a mean of a histogram, it will be about forgetting the cases. Because otherwise it's not a mean of a histogram. It's a mean of...
My question relates to that. I was wondering, if I understand correctly, you have a lot of questions about building histograms and what a histogram is and the relation between case value plots and the histogram, but also many tasks about finding a mean. in Instagram or in case value plot. And I was wondering why do you find it so important that students can find a meaning from Instagram?
Yeah, that's a very good question. And if you look into research, most researchers don't like that. They take variability. So the variation in a case value plot and the variation in the histogram. But there are two reasons why I don't use it. One is very practical. I'm working with secondary school students who do not understand the concept of variability anyway. So if I use that, I'm sure that they won't understand the how you apply that in the histogram. But then I'm not testing what I want to test. So that's a practical reason. And I know very sure that they understand at least a big part of what a mean is. They can calculate very well their mean for mathematics. So that's one reason. But the other reason is if you talk about variability, it's also always the variation around something. Usually, standard deviation is the variation around the mean. So if you think about variability in a graph, although you might not be aware, you have something like a mean in your mind. Because otherwise you can't talk about variability at all. So we see finding the mean as a kind of precognition or voorbereidende oefening. How do you say that in English? Preparatory exercise or thinking process for the idea of a variability.
I'm thinking whether I agree with that.
Okay.
When you compare two histograms, you can compare the amount of variability in those histograms regardless of the mean, although you would have to say something about scales, maybe.
Yeah. Yeah, you are right. And we put those tasks in this as well, but then with the mean, but that's the same. And what was interesting that, for example, one of the teachers was very well trained in histograms. So he said, he gave all the correct answers to the histogram questions. And then I gave him 2 case value plots. And one of them had less bars than the others, but they were kind of symmetrical and look equal apart from those 2 missing bars. And then he said, well, in the one with more bars, there is more spread in this way. Whereas actually with the one with the missing bar, so you have 0, because there was a name attached to that 0 bar, and with the same highest bar, there is more variation. So for me, I don't think there is a big difference between understanding the mean and understanding variability. If you don't understand one of them, if you don't understand the mean, I don't think you can really conceptually understand what variability is. Or take another measure of center. I'm not attached to the mean. You can use the median or whatever measure of center you like.
Some other question?
Yeah. Do you think it was the idea to, with the sliding task, it was the idea to test if the students grasp the concept of a mean as what Paul says, the moment weight distribution in the graph. So was that concept also introduced when they performed the first task?
No. You mean in the task that we showed here?
Yeah.
Yeah.
When they needed to find the means without.
In the eye tracking, no.
So did you consider to introduce that concept not with embodied cognition, but just by introducing the concept and to see what happens?
I didn't consider it yet, but actually it came up from the pilot study because as a teacher I wasn't familiar with that yet. I didn't know that you can find the mean in that way. And one of the master students that was a participant in this eye tracking study, in this pilot, he explained it that way. Yeah. But what I saw then is actually a bit similar to what the teacher was doing. this student was so familiar with histograms that the explanation of the case value plots was as if these were histograms. So that isn't really answering your question, I think, but...
Because you did two things. You introduced a new concept and you did it via an embodied task.
Yeah, yeah. We'll think about that, thank you.
And what was the result? Yeah.
We haven't piloted it, yes. No, this is like, we are talking about our ideas and we're collecting your feedback to improve the design before we test it with students. We tested with like one child. I tested with my son, who was in ZVWO by then, and she tested with her son, and we got some feedback, but that's the only testing we did right now. So I can't tell you how that would work. It's an feedback that we take with us for the design. Yeah. Monica. Nee?
Different question, but that's okay. I was wondering whether you also have tasks where you change the width of the bars. Because I think for a histogram it's very important to see what happens when you change the width. So you see those. And I think, well, this one do you have these already? Or
no. Well, we have some ideas, but technically we didn't have it working yet. But we had some ideas about that. And we also looked into, shall we construct a density histogram where you have unequal bin width? And the interesting thing is, if you look at a gap in the literature, this is a huge gap. There is not much research on that, but you also encounter many problems because most professional software for statistics doesn't provide this option. So, and in Excel, it's you really have to make it yourself. It's not ready available. No. But if I say statistical, I mean SPSS and R, and well, name them. Yeah.
I'm relatively new to embodied cognition, but I was wondering, you could make this thing, this scale physically, right?
Yeah.
You wouldn't. You'd have to be very light, and the weights that you use to fill the bins would have to be relatively heavy.
Mm-hmm.
Would that, have you considered that? Would that help secondary students with it? You could physically make it. You could have them physically fill the bins, and then slide the balance point over a balance scale.
Yeah. I haven't thought of that. It's a very nice idea.
Actually,
Then they would learn how to
Who did?
With the distribution.
Okay.
But you want to understand what's behind it, I guess, mathematically, and not just by playing around learning that this is a trick to find meaning.
Yeah.
But yeah, it would help you grasp this concept, I guess, of sliding where the point where the mean is. You're thinking
Yeah. I think there has to be, you have to do a lot more before you get into that point to understand what you're really doing.
Yeah.
And that's what I'm missing in this proposal.
Yeah. So I also teach this to my students, which are not secondary, but I have them decide for themselves the bin width, right? So we take the height of everybody in the class, and then we ask them, well, how can you make a nice diagram out of this? Because they should have had this in secondary education. So you could have to do that first, and then...
All right, Michiel?
A bit related to this issue. As you state, one of the questions is, do we need more tasks? That gives a kind of suggestion that the learning of the students progresses along these individual small tasks. I think we also need to discuss bigger issues, like Kuno said before, with in between you proceed from one task to the other. So, do you have the idea that you can solve, or that you can improve it by adding tasks, or also by adding other ways of dealing with this problem and these issues?
Yeah, when I say task, I don't mean per se task in a digital environment. Although I wouldn't think of a classroom discussion as a task, but we thought of adding that, definitely, because we know that from classroom discussions, sometimes that is the moment where the learning occurs and not in the task itself. So, yeah, but if you have the suggestions for that, please let us know. Yeah.
Well,
Rosa, or do you want to respond to this? Rosa first and then...
It was actually following up on this discussion, because I really like that tree with the scale, but I have the feeling that the technology is doing actually a lot for them, and they're looking where is it balanced without sort of knowing or enacting how you would balance that. Because we have to sort of weigh themselves and see where it is, and now it's the skill itself that is weighing for them.
Yeah, so you suggest to do something before that? Or, yeah.
Yeah, or at least investigate how you would sort of embody this scale, how they would have to do it, how they would sense that.
You want to respond?
Yeah?
Yeah, I want to respond. Yeah, the idea is that just doing it may align them with some intuitive experience, but then of course there is a whole range of tasks is needed in order to, as you say, understand mathematics behind it, like for example, make 2 small bars and enlarge 1 bar 2 times and see what is changing. And it's not about just playing a thing and putting it in the correct way, rather predicting where it should be and then checking. And it's not thought like just put it in the correct way and then you will know it. No, it's more about this kind of interaction of prediction and then figuring it out.
And giving arguments. Why do you think it will be there? That will be an important part, I think.
Yeah, I think Kuno was already wanted to say something.
I was wondering, are you going to design an instructional sequence?
Am I going to design?
An instructional sequence?
Yes, that's what I'm aiming for at the end.
And what are the design principles in your sequence that you're going to design?
That's a good question. I'm still still developing the ideas behind this sequence. So, well, it's clear what I'm aiming for, at least for myself. I want my students in the end to understand the key concept of data and distribution, and a histogram is only a way for me in which the problems manifest themselves. So when I look into design principles, I will look for principles that will help me with this aim. But yeah, and I don't have a clear answer yet. Yeah.
I was wondering, the prior knowledge of all students have about the mean, how does it connect to the balance you use here? And is there a possibility that embodied cognition can do something about the knowledge of all students they have about mean to this concept of the balance?
Do you mean that when they understand this idea of balance, that it will help them?
And they start, they have problems to understand histograms.
Yes.
But every student has an idea of what is the mean.
Yes.
They all calculate the means of their marks. So is there a possibility that you can connect that idea of mean to this concept of balance, where it's also
okay.
And probably the role of embodied cognition in this.
Yeah. Thank you.
Yes.
Chris, yeah.
I was wondering how you are evaluating the task. So what kind of classroom data do you use to see how thinking changes, for example, of the students?
Yeah.
Interviews, you said something about interviews after the task?
That was in the eye tracking design. In this, well, there are several ways we can collect data. Big and small interviews are one of the possible ways, But we also thought about designing a small assessment at the beginning, so before and after. But that's something that we are still developing.
Are
Yeah.
the teachers involved?
Not yet. That will be the next step. Yeah, because we thought of involving teachers right now, but I think what we are doing is so much far away from teaching practice that we need more concrete tasks and a sequence of tasks before we can discuss with teachers and get feedback that we can use, that is useful for the design. Yeah.
So I thought that it was this asked question about design principles coming from embodied cognition. And I think that's quite a good challenge for embodied cognition, because there are a lot of design principles coming from classical cognitive psychology. For example, cognitive loads during watching a video animation or something, and to channel ideas about visual and audio at the same time. But is there, are there similar sort of ideas, principles coming from embodied cognition?
If Lonneke don't mind, I can articulate a couple that were used here. There is an initial principle of embodied design, which is presenting a mathematical concept in form of a motor problem, and that would lead to development of new sensory motor coordination. In this case, coordinating of a height with an amount of balls, so coordinating the position, a particular case with the position of a horizontal line. This is one principle, and another principle that basically I'm working with for the last year is an idea that an artifact emerges for the student and it already reifies some actions. A height of a bar actually materializes that I could build it. So we use as a design principle kind of deconstructing artifact and suggesting a student an opportunity to enact and then reifying what previously was enacted. And this is the second design principle.
I think it's very intriguing because these concepts really are abstract, they are not embodied. Mean, distribution, they come from thought, and you find ways with multimodal learning to help students understand them better, so it's working. But what kind of embodiment is this? Is creating new ways to experience the world? I think it's the other way around. You don't start with those concepts which are embodied, like we are attracted to the earth, so we understand weight from our bodies. But that is not the way you proceed.
No.
You use action and sensing as extra to just thinking, so not just cognitive working, but also sensory motor thing. But is that what kind of embodiment is this?
Yeah, I think Arthur wants to respond to that.
It's a very interesting point, because when most people hear about embodiment, the first idea is that it has to grow from the bottom up, like sensory motor experience as a baby, etc. It has to grow naturally until some magic mathematics, right? Like with a Nunez kind of order. But what we are doing also with the proportion task is exactly what you said earlier. You invite students to they are gaining a particular experience, sensory motor experience, that is the solution to a motor problem. And that is supposed to help and reflect on and better understand the mathematical concept. So it is artificial. It's not something you would learn in your daily life normally, unless you are blowing up pictures or whatever.
Daily life normally for something.
But I think as you're hinting at, it's the sort of reverse giving experience.
Perhaps you can find traces of that in the way students start speaking about distribution. If they use wording like sliding, or if they use this what they have been acting should be reflected in the speech in a metaphorical way. So
the gestures.
yes, they make gestures. So
so with proportion, we have these tasks where they blow up things, and then if they have to make a bigger triangle on paper, they indeed explain with gestures like that I have been using before. So that there are indeed that sort of central motor traces, so to speak, in communication.
And obviously you still use three-dimensional worlds. And
Okay. It's 5 o'clock now, which means it's officially the time we can drink alcohol. There is a policy at our university that before 5 o'clock we cannot serve any alcohol. It's terrible, but it's the way it is. We get French visitors, they will not have their wine for lunch. But we will have drinks in a moment, but not before I point out that we haven't applauded Lonneke to start with. Thank you very much, Lonneke.
Can I say one more thing?
Yeah, of course.
Because I'm very proud that today my first scientific article is online available. So please make a photo of this screen and go to my first article and read it. It's all about data and distribution. Okay, thank you.
And then there's this remark that I forgot to send around this forum, which I'm going to do right now, which you could also sort of fill in.